Hello everyone, amateur meteorologist. First and weather here. It is January 18th, 2023, and we have an interesting pattern coming up for the next couple of weeks. Obviously, this winter so far has been quite a disappointment for many snow lovers and winter weather enthusiasts along the East Coast, and especially along and east of I-95. Of course, in December of 2022, there was a record-breaking NAO event with height anomalies in Greenland, many standard deviations below the average. And so many thought that with such a record-breaking negative NAO, a favorable upper air pattern, that a snowstorm was pretty much a guaranteed bet for major cities along the East Coast, and that there could even be multiple snow events along I-95. And unfortunately, for a variety of reasons that I won't get into this video, but that just did not happen. And what ended up happening was you had a snowless December for most of the East Coast, and instead you had a very potent Arctic outbreak from December 23rd until the 26th, with widespread record-breaking cold anomalies. In fact, it was some places had their coldest or second coldest Christmas on record for areas east of the Mississippi, and the cold is very, very widespread, but again, along with it, not really too much snowfall to speak of. And since that cold outbreak in late December, we've experienced a massive January thaw with this current PRISM temperature anomaly analysis shows temp anomalies from the 1st of January all the way to the 17th. And what you'll see is that a widespread of pretty much the entire country, besides the far southwest and the western U.S., is seeing well above average temperatures. Don't let this color bar fool you. This brown to light brown is temperature anomalies of 5 to 10 degrees above average for the first 17 days of the month. And this light red is 10 to 13 degrees above average temp anomalies, which is just mind-boggling. And you can see right here, Western California is the only area that's really seen, or Central and Western California is really the only area that's seen below average temp anomalies. So again, a very warm start to the year. And now we can look at sort of how that projects into the overall winter severity. This is the winter severity index, which kind of just goes to show how this winter is compared to average. So purple means this winter is really extreme compared to your typical winter, while the red dot means very mild. So the winter is sort of being much milder, much less snowy than a usual winter for that area. And you'll see that winter has pretty much been non-existent over the East Coast. Deep reds for the Northeast, the Mid-Atlantic, the Ohio Valley, and the Southern U.S. And the only areas which are really seeing an extreme to severe winter are the Midwest and Northwestern portions of the country. So now let's take a look at the GFS 18Z run and just take it through time. You'll see that we have the mid-latitude cyclone moving through the northern part of the country, some rain showers for the Mid-Atlantic, some prefrontal warm front snows for the interior Northeast, maybe for a couple hours, but no real accumulation there. And so after that departs, maybe some residual lake effect snow showers in the Northeast, but nothing really to write home about. And that takes us to the 21st. So you have pretty much a rather zonal flow in the East Coast, a trough ejecting out in the central U.S., and that leads to our next system. And here the GFS shows sort of a negatively tilted trough or neutrally tilted trough with a low pressure developing in the southeast, which then rides up the coast, transfers its energy offshore, and you have a snowstorm for the interior Northeast. Now, there has been a lot of variability with the model solutions, but I do think this general picture is overall correct. Now, if we look at the GEFS ensemble for the 23rd time frame, and you take it to the 23rd, you'll see that, again, what's really happening is you have this system right here that ejects from this trough. And so this trough right here weakens, and it kind of moves right under the Northeast. And so because of that, you have a low forming, and you have snows on the cold edge of the low. Now, it's important to keep in mind, however, that there isn't really going to be a very impressive cold source with this system. So if we go to the 23rd, you'll see that this low is tracking up the East Coast, proxy of that trough, and there's no high pressure supplying cold air in. In fact, there's just a low to the northwest, so actually there might be some warm air advection just not too far west of the low. And so that kind of just goes to show that in the wintertime, especially during peak climatological low minimum temperatures and high temperatures, that even with above average conditions, you can still see snow, especially in interior portions of the Northeast during the winter time. And if you look at the temp anomalies, you'll see that they're actually quite a bit above average. This is for 6Z on January 23rd, take it to 18Z even, and still you're seeing temp anomalies that are quite a bit above average. And so that goes to show that this setup will be quite marginal, especially for low elevation areas. So this snow event, again, is looking to be quite elevation dependent. Now, if the low does strengthen, it can sort of produce its own cold, so to say, but again, it's looking like a rather marginal event with temperatures in the low 30s, maybe even flirting with 32, 33 in the lowest elevation areas if this system does indeed materialize. Now, if we look at the GFS ensemble plot and look at precipitation by member, you'll notice that in general, over the past couple of runs, the GFS model has increased its confidence in sort of a interior snow event. Previously, it was showing a more northwesterly track, but ensemble is just we're not supporting that. And instead, you can see that the GEFS shows a system tracking up the east coast and snows on the backside and on the northwest side. And when looking at ensemble snowfall accumulation, you'll see that in general, it shows about 3 to 6 inches of snow in this northeastern corridor, and then this gap right here again from elevation and unfavorable terrain. But again, not too bullish on anything significant right now. I think this could change. At this point, just sort of a wait and see game. Now, if we go back to the GFS ensemble right here and look at ensemble member MSLP just to see the cluster of model solutions, you'll see that there's been a pretty modest increase in agreement that there will be a low pressure system right off the East Coast tracking up north. And again, this doesn't really pose much of a risk for I-95, if any, because there's no real cold source. And in fact, you have a high pressure to the southwest, not really doing anything, a low to the northwest, actually even bringing in some more air advection for areas west of the Appalachians. So there's no real cold source. Temp anomalies are above average, and so this will just be a cold rain for most areas along and east of I-95. Maybe far northwestern Virginia could briefly start and end as snow, but no real accumulations there. The real snow risk is really going to be confined to these areas right here that I'll draw really quickly. Right, essentially your typical interior northeast snow event. And again, this is not looking like a very big blockbuster type event, but rather just a moderate snowstorm potential, maybe even light moderate snowstorm or light snow event potential. It's nothing really too serious. Now, if we look at the polar weather GFS and predominant precipitation type, you'll see that the GFS is sort of picking up on this. It shows that low pressure off the coast, rain along the coast and just inland, and some snow on the backside. Now, if we look at the EPS sort of height anomalies as well, you'll see that there's, in general, pretty much a very similar story. The EPS is a bit more pronounced on the shortwave ejecting, and so it does have a bit a stronger system, and that would promote sort of colder temperatures, more snow, more precipitation, and that will be interesting to see which ensemble turns out to correct here, to see which one is more accurate. But if we look at the 48-hour trend in heights, you'll see that. Let me go to 0Z. Oops, not loaded yet. Let's switch to the GFS ensemble. If we go to the 48-hour trend, you'll notice that. As you can see right here, there has been a trend for a deepening trough. And so that is a good sign if you want more snow in the interior northeast. Indicates a stronger system, more cold air in place. So that would help promote seeing an increased chance for a moderate to a significant snow. Now, switching gears and going to the long term, I think after this 23rd system, not really too big of a deal, just some moderate snows in the interior northeast are possible. But after that, if we go to the height anomalies, things definitely do turn a bit more interesting. You'll notice that on the 22nd, we have a pretty strong negative NAO, negative EPO, which is nice. It allows for a cross-polar flow, but this negative NAO really makes the jet stream not too wavy. But after that, models do tend to build a negative NAO, and this trend has been increasing. You have a negative EPO, slightly elongated polar vortex, and a negative NAO, and that allows for cross-polar flow, and this negative EPO right here forces a downstream trough to set up over the central U.S., And I think this is a window that can possibly lead to some wintry weather. You'll see that this trough sort of lingers around up until the end of the month before that southeast ridge makes a return for February. And this sort of matches up quite well with the analogs that I used for this winter forecast, because February was expected to have a dominant southeast ridge with their mean trough axis being in the central and western United States, bringing all the cold and snow to the west, while the east stayed wet and mostly warm. And so essentially what this depicts is that our main window of opportunity for any winter weather lovers before March is the next couple of weeks. So basically after the 23rd, up until the end of January, I think, is when conditions will turn a bit colder than average. If we look at temp anomalies for this time period, you'll see that that cold does sort of propagate to the east. Nothing too impressive, but also not a blowtorch. So if there is a window for some snow opportunities and winter weather chances, it will be the last week of March especially, but before things turn back warm. And if we look back again at the height anomaly forecast from the EPS ensemble, you'll see that it does again show that ridge building in as you go into February, which lines up quite nicely with my analogs. Now, switching gears to the polar vortex and the stratosphere, there has been some buzz of a potential sudden stratospheric warming event, which again is when wave reflectivity propagates energy into the upper levels of the stratosphere, and that essentially leads to the warming of the upper levels of the atmosphere. And that causes downstream effects where, in many cases, the winds actually reverse to being easterly. And that causes a whole cascading effect where if the stratospheric conditions couple with the troposphere, you can have the development of a negative NAO and very cold weather for the eastern seaboard and the mid-latitudes. Now, this right here is the GEFS ensemble and CFS wind forecast. You mean wind forecast for 10 hectopascals at 60 north. Now, a value below 0 meters per second indicates a sudden stratospheric warming event or a polar vortex disruption. And you'll see that both the GFS ensemble and CFS, with this particular model run at least, show that criteria being met of SSW event. And so that could potentially have big implications for our winter after February. I think February is pretty much guaranteed to see warm, in fact, possibly very warm conditions for areas east of the Mississippi, with the main cold and snow being forecast and being centered in the west. That's also what you typically see right before or right during the first 3 or 4 weeks of an SSW. Research by meteorologists like Jada Cohen shows that during an SSW event, the first 3 to 4 weeks tend to experience very warm conditions in the mid-latitudes, especially in the East Coast, with a dominant ridge, before you see that cascading effect of that negative NAO developing and those cold temp anomalies reaching the mid-latitudes. And so this lines up quite nicely with my analogs as well, because my analogs were showing a warm February and a very, very cold and wintry March for pretty much the entire U.S. And so this lends more confidence to the idea that an SSW or significant stretching event or disruption in the polar vortex could occur in February or late January, and then that would lead to a warm and wet February for the East Coast, but then also a very snowy and wintry and cold March for the lower 48, especially east of the Mississippi. So this is something to watch, and I'll be posting updates on Twitter and might even do another YouTube video discussing this. And this right here is a loop of the GFS 10 millibar forecasted temperature. And you'll see that we have a lot of heat flux into the upper levels of the stratosphere. And that disrupts the polar vortex, according to this model run, and sort of forces it down into the mid-latitudes. And that can have big impacts on our weather here in the lower 48. So again, something to track. It looks increasingly likely that the vortex will weaken. The main question is how much? Will there be an SSW event? And will this couple with the troposphere, and will we see downstream impacts at the surface as we head into late February and early March? That's it for this video. I hope you enjoyed, and I'll see you next time.